Good morning, everyone, and a warm welcome to this webinar hosted by Rockflow Dynamics. Thank you very much for joining us today. My name is Joanne. Today I'm here with my colleague Alexandra Kidd, who will be presenting this webinar. If you haven't joined one of our webinars before, this is how it will work. All of the attendees online today have had their microphone automatically muted, so if you would like to ask a question, please use the control panel on your screen and type your question in there, and we have some time at the end to answer the questions. If we don't have time to address your question live, we will make sure we follow up with you via email. The webinar is being recorded and we will upload that to our YouTube channel later on. And if you'd like any more information, you can email us on asktnav@rfdyn.com. We will be covering a variety of webinar topics in this 6-part series running over 3 weeks. You can find last week's presentations along with all of our previous webinars on our YouTube channel. In today's presentation, Alexandra is going to show you how you can couple field development planning with economic modelling in order to determine the best strategies in terms of financial outcome. This will be done using tNavigator's optimization tools integrated with Microsoft Excel via Python scripting. In our webinars, we show you a wide range of demonstrations from each stage of the integrated workflow inside tNavigator. If there's a functionality that you see that you haven't used before and you'd like to hear more about it, don't hesitate to get in touch with the team for more details and trial licenses. So now I would like to hand you over to Alexandra to begin the presentation. Thank you, Alex.
Thank you, Joanne. And hello, everybody. Welcome to this webinar, and thank you very much for your time. I hope you would be very interested to find out how does it work, how can we do the economic optimization. So I'll go through some slides to introduce the topic. I also will do the demonstration to illustrate the point. Economic analysis and optimization help us to evaluate multiple development scenarios and also optimize them based on specific criteria. For example, if we want to maximize oil production, that would lead to the maximizing of net present value of the investment. There are other important economic indicators that could be considered during optimization studies. For example, in this one, we also look at parameters such as discounted profitability index and benefit cost ratio. So today we're going to see how we can integrate economic analysis, optimization using Python, where we will be connecting tNavigator software with Microsoft Excel. Our agenda today is as follows. I will introduce the optimization project and describe what are the main objectives for today. Then we will look through the economic model, Python scripting. After that, we will have a look how to actually set up the optimization project. And of course, at the end, we will review the results and make some conclusions. As Joanne mentioned, we also have time for questions and answers at the end of today. Let's start by introducing the challenge. We have a field with 7 producers, and we would like to perform water flooding and to add 5 injectors. So the main objective in this case would be to run and compare multiple water flood strategies to ensure the highest economic efficiency. To perform the optimization, we would like to answer the following questions. When to start the injection? What is the optimal injection BHP control value? And what is the optimal water cut economic limit for producers? So that would be these questions for today that we will review in our demonstration as well. To answer these questions, we will introduce variables in our optimization study, and we will also use optimization algorithm to search the parameter space to be able to converge towards the optimal solution. All the economic parameters, such as, for example, net present value, discounted profitability index, benefit cost ratio, will be calculated in Excel using the initial data, such as, for example, oil price, tax rates, operational expenses, and so on. So you can see that we connect our Microsoft Excel, where we start with initial data, with tNavigator, where we would put outputs from the tNavigator after some calculations back into Excel, and then perform the calculations. Some of the outputs that we will put in Excel from tNavigator are, for example, oil production, water injection, number of working wells, as well as the start of the water flooding. The Python script will be used for that. So if we go step by step, that will be the following order. The Python script will help us to create a copy of the Excel file with the initial data and economic calculations. After running the dynamic simulations, we can extract the results and output them into Excel file. Our step number 3 will help us to recalculate parameters based on the tNav outputs. And then we can use the calculated benefit cost ratio as a user graph in our optimization project. This is a very important step because it helps us to put the specific parameters that we then use for optimization inside the tNavigator software. So our step number 5 would help us to use the user graph as the objective function. The objective function is the drive of the optimization process. So that will help us to progress and search through the parameter space to find some optimal combinations to achieve our final objective of the project. And our step number 6 would use the new variant to run our next simulation case. And as you can imagine, then we need to repeat the steps until the objective is reached. We can now investigate a little bit more the Python scripting, especially if you really like doing scripting, you will enjoy looking through the slides. We try to always put some comments, so if you want to start using Python but not always feel very confident, there are some examples and some comments that could be useful for you to understand. So for example, first of course is to import the libraries that would be used for the example. Then you need to do all kind of the setup where you specify where the project is located. How do you create the new graph? How do you do the copying of one file and introduce the new file? We also need to have a loop because we will repeat this process multiple times. We need to specify how do we collect all the data and where do we store the data. There are a couple of steps to tell that we open Excel, then we define all the necessary parameters in there, copy all the results, and then calculate, in our case, the benefit cost ratio that is used as the objective function. So you can see that we specify our user graph as 2 points, where we have the first time step, which is a 0 value, and the last time step where the actual calculated benefit cost ratio value is. And then we write the results. So this is very good as you can modify scripts to change it in terms of your own objectives. And we hope that having some examples is useful to get started. So now let's look at the steps that needed to set up the optimization project. First of all, we're going to open the simulation model. We will be able to run it and at the same time to visualize the results. So in this step, we just want to have a look at our initial case and how we progress from just having a model and using it to set up the optimization study. So first, after we start running, we can see that we can work with the model whilst the calculations are going. So currently we only have the producers, and at some point we will introduce the injectors around the producers. In this case, we can look at different maps and then decide how we want to specify our variables. In this case, we will use specific keywords. So you can see that we introduce the variable straight into the data file. And as I mentioned before, we use our injection year, our BHP, and water cut as variables. So the first step is to define them, and the second step is to actually put them in the schedule. So you can see that we use different keywords like we would do normally, and then instead of the value, we introduce the variable. So that means that we're going to go through different combinations of the parameters in the defined variable range and evaluate what combination can give us the highest value of production. So when we have all the variables defined, we can then create the project. So in this project, we're going to use the variables, and then we're going to connect that to the Python script to be able to create all the necessary Excel files. So let's have a look in some more details how we can do that. So first of all, after opening the new project, we would need to do one custom run. So that's to be able to create some outputs from tNavigator and to be able to use our Python script. The custom run would just use the base value that is defined in our variables, and based on that, we will get some calculated results. So as soon as calculated results appear, we can visualize them in different forms. We can see them in graphs, as well as we can see them as tables. So that could be very helpful. So you can set up the view to see multiple results in different ways. As soon as you're ready, we would just need to bring the Python script, the one that we reviewed in the slides, in our graph calculator. This is where the Python would be executed. And as soon as we have the calculation, it means that we did the steps of copying Excel spreadsheet, doing some calculations and outputting the first results in there. So you can see this is the same script. We just need to say calculate, and to be able to see that results are complete, that means that we are ready to go. So just for your information, let me show you how it looks like. So you can get the list of all the Excel spreadsheets. And as I mentioned before, we have our tNav output from our first run in here. So now we're ready to use that for the following steps. We would like to visualize our user graph, which is benefit cost ratio. As you remember, there's 2 points, and the second point is the actual value, the total value, at the last time step. We're going to use this graph and set up as our objective function. To create the objective function, we're going to go through several steps. First one, we're going to create the new objective function, where that would be our empty canvas to identify what are we going to use as our objective. So we're going to put benefit cost ratio, and we're going to set up several different points. First of all, we need to define a function type as an optimization, as our forecast optimization. Next one, we will set up the user graph option. This is the type where we can now pick up the benefit cost ratio. And the final thing is to do maximization mode. So as soon as all set up, we can now start the optimization using the just created objective function. In terms of optimization, we have a variety of algorithms. So you have several different ones to choose, and some of them are normally using quite a lot of simulations to go through. But when we're working with small number of variables, we actually can do a slightly less number of realization to go through. So after we set it all up, we can just start, and as you can see, all the optimization runs create a queue, and we'll just go one by one through that. So when we work with optimization, it's very important to know what's the kind of the stopping criteria for that. So for example, in our case, we set up the number of runs that we want to go through. Working with different models, that could be something that you can decide when you work with the model closely. For example, the number of variables and the complexity of the model is very important, and that could affect the number of runs that you need to perform. After we run all the simulations, we can review the results. The benefits of the technology is that we can run quite a lot of simulations and therefore have a good big picture about different trends and results. Again, having the different tools to visualize the results is very helpful. So we're going to review several of them. For example, we can look at our benefit cost ratio as a cross plot, plotting number of variants on one axis and then the other one on the other one, and see how it's changing. We also can review our graphs and visualize our final results of our oil total, water total, injection. It's quite interesting to see what widespread we can get, and it feels that for injection, because of the different years, we have kind of groups and clusters of different runs starting at different years. Apart from graphs, it's quite useful to visualize our objective function value in a table format. When we work with a table, we can do some sorting. When we do the sorting, we also sort all our variables. So we will see the combination of variables together with the objective function value. So that could help us, especially when you have not too many variables, to kind of get an idea what combination gives you the highest results. For example, in our case, as you can see, the injection year is always the same. So the early start of injection can give us the highest values. So we can select these models, the ones that give us the highest value, and work with them separately. So I'm going to show a couple of interesting ways to work with your models. For example, if we select just the ones that give us the highest values, we can visualize them on the graphs and on the cross plots. So in our cross plots, we can see again the distribution of our variables and can kind of get a feeling of what are the ranges that can give us the highest value. So now I set up the way that we have them in our model position and list. And again, you can see some of the variable distributions are quite close, quite kind of narrow. So for example, here, for the water cat maximum value, this is the highest value to start with at the beginning, right? So this range from somewhere about 0.88 to 0.89, which is not such a huge range, will give us the highest value. Whilst here we see at this area that still giving us the highest value, but the less, and the range is actually getting wider. So we can look at this parameter strip to analyze them in more details, and at the same time we can look at our graphs and see what are the ranges of our parameters such as oil production and water production that we get. It's kind of interesting to see that the oil range is narrower than the water total. And if we want to look at our benefit cost ratio, we can see that this value doesn't change too much for the highest values. It's not always the case, but again, can give us more insight. The other ways to work with our variables could be to add some more kind of perspective from the highest cases against the total distribution. So for example, we can use some coloring to separate the highest cases from the rest. So currently we should change in the color, and then we see our results in two groups. So the wider kind of pale orange ones is all the cases that we run, and the red ones are the highest values with objective function, which is distributing to the highest value of production. And we can see how the range is different. So we can narrow the range by picking the highest value for us. Yet we're not limiting just one model. We're kind of looking at the whole distribution here, which can give us a good understanding of our risks as well when we select some specific planning. We also can then progress very easily from all these models and distributions and graphs and pick a specific model and start working and looking and playing with some specific model to understand a bit more and visualize results and see how it works. So that was a very, very quick demonstration of different ways of setting up the optimization study. And it was mainly to give you a flavor today to understand or to think of some ideas what we can do and what can be useful for you. To sum up, we saw how we can do the integration. In this case, we integrated the economic analysis and the optimization field development planning. Python was very handy in this case. Without really going too much into coding, we use Python as a connector between tNavigator and Microsoft Excel. And just to remind you that in this specific example, we used the test case with 7 producers and 5 injectors. And we were answering some specific questions. When to start the injection to give us the highest value of economic investment return. So we answered that one. We also looked at what would be the optimal injection BHP control value. So we picked up several cases. And finally, what would be the optimal water cut economic limit for producers? Again, we picked up some cases and looked at different combinations. It's very difficult to do manually, especially if you start having more different parameters involved. Trying to find the combination, you need to go a lot of changing, checking, and so on. So having an option to do it automatically can give you a lot of freedom. This methodology is not limited to this specific example and could be modified to evaluate other scenarios relevant to oil and gas industry challenges. So our final message is, please give it a go and also let us know what other interesting challenges you were thinking about whilst watching this webinars and thinking about your own challenges. At this point, I will pass back to Joanne, and thank you for your attention.
Thank you very much, Alexandra, for the presentation. I'll just give Alexandra a minute to look through some of the questions that we've got coming in, and just quickly remind you that we have quite a wide range of webinars on our YouTube page now, so make sure you check those out. And our next session will be on Thursday, and that's with Jessica and Horatio, which is match your model using repeat formation test data. And just a reminder of the times of our webinar, so you can check the time that's local to you. So I'll hand it back to Alex. Do you have any questions there to answer, Alexandra?
Yes, Joanne, we have a few. We'll see if we can do maybe a couple today. And as Joanne mentioned before, we absolutely will follow the rest of the questions by emails. So for example, the first one is, does tNav has Python embedded, or do you need to install it separately? We actually have two options. So to answer the question, we can say that we have Python, so-called Python interpreter in tNavigator. So when you install tNavigator executable, you get some of the Python libraries that need it for calculations already, so you don't need any additional setup. But at the same time, for other tasks, you might need an external Python interpreter. That would mean that you would need to have an additional setup, and we would recommend Python 3.6 as a good one, as a very good compatibility. For example, in this webinar today, we needed to download some extra library to the one that would be able to help us to connect with Excel. But again, if you need any help with that, we are happy to help. And one more question is like that. Is it possible, or is it planned, to connect the economic models from third-party software? And so this softwares that I mentioned here as examples, I'm not familiar with, but I think that would be a very good point to check and have a look. What do we have planned? Because as you can see, we're already kind of connecting to third-party software, which is Microsoft Excel, and it's been very useful. So I will investigate to see what's our plan to connect to any other softwares.
Cool. Okay. That's us just out of time, Alex. So as we said before, if there's any questions that you have, we will follow up with you later on. So thank you very much, everyone, for joining us today, and we hope to see you on our next webinar on Thursday. Thank you very much. Enjoy the rest of your day.
Thank you. Bye-bye.